In this video, we're just going to talk about transversals intersecting three parallel lines. So we can see from our diagram here we have parallel lines K, L, and M, and we have the transversal lines T going through points A, B, and C, and H going through points P, Q, and R. Now, as with any other transversal lines intersecting parallel lines, they create angles that we can say are equal to each other. So there's corresponding angles marked like that, or there's alternate angles, which will mark over at P and at Q, or there's vertically opposite angles, which are marked down at R. So all of those properties would still be the same. But in this particular video, we're looking at a different property, and that would be if three parallel lines cut off equal segments on some transversal, then they will cut off equal segments on any other transversal. So on the transversal T, we can see that AB is equal to BC. That's what the two small lines on it mean. And because our parallel lines have done that on transversal T, any other transversal drawn through these three parallel lines will also be cut into equal segments. And just for clarity's sake on this, the two sections on T are not equal in length to the two sections that are shown on H over here, but they are equal to each other, and the sections on H are equal to each other. So let's just take a look at a few examples, questions of this, so we can get an idea what's going on. Alright, so we can see in these diagrams, L, M, and N are parallel lines, and they cut equal intercepts on the transversals. So from this, we can work out the values of the variables in this. So for example, in the first diagram here on the left, if the parallel lines are cutting equal intercepts on transversals, and that would mean that x is equal to 7 and y is equal to 5. Very clear in this, y is not 7 and x is not 5. The values are relating to measurements on the same transversal line, not opposite ones. And if we look at the other example over here, on P, we can say that 3x is equal to 12, which means x is equal to 4. And on the other side, we can say that 4x equals y minus 6. But we know that 4 is the value for x, so 16 equals y minus 6. So y is going to be equal to 22. So that's how it would work for these examples. But this still holds even when you get diagrams with three transversals, like this. So in this one, we can see that A, B, and C are the parallel lines. P, Q, and R are three transversals this time. So we're looking at three different transversals. And they're intersecting A, B, and C. And you can see clearly marked on P that P has been cut into equal sections by the three transversal lines. So the distance between D and E is the same as the distance between E and F. That means that G to H will equal H to I, and G to J would equal J to K. So if we look over here, we can see D to E equals E to F, which is what we just said, and we're told GH equals 8. So there's a value of 8 in here, and JK equals 7. So that would mean that HI, since it's on the same transversal as GH, and the parallel lines have cut other transversals into equal sections, HI is equal to 8, and GJ, this point up here, is on the same transversal as JK, which we were told is 7, and as we've previously stated, the parallel lines are cutting the intercepts into equal sections. So GJ is also going to be equal to 7. And that is that.